Alright, continuing on here for Lab 4, this will be our last video. We're going to make the assembly file for the full pump. To do this, of course, we'll click New under the File menu and open up Assembly. Now, it's asking me to begin the assembly process by selecting Parts to Insert. I'm going to select the first one, which will be the well casing, which we'll scroll down here and select well casing, and then press OK, and I'm just going to place that in space there. Now the first part that we select is fixed. You can tell here because it has the F, which means that this part here is fixed in space. It can't move in any direction, it can't rotate in any direction. And this is very important because we consider this our base part and we assemble everything else based on this base part. The next thing which I'll insert, if I go to Insert Components, is the well seal. Okay, so I'm just going to go ahead and place that in space. I'm going to right click here and click Float to make sure this part is not fixed as it previously was. And now I'm just going to drag this guy out here in space. Now I'm going to go ahead and click Mate, and I will mate the inner cylinder here of the well casing to the outer cylinder here of the well seal, and it's going to create automatically a concentric condition, which is perfect. Then I'm going to go ahead and slide the well seal up, and I'm going to create a coincident mate by selecting the top face of the well casing and just zooming out here. Oops, I'm going to select the bottom face of that well seal there, so you'll see they line up coincidentally by default, and I'll go ahead and press OK. Now we'll zoom out back to the full assembly. Next, I'm going to assemble the T. So to do the T, I'll insert my T right here and just place that over there in space. Same thing, I'll select the cylinder of the T to match the cylinder here of the seal. Then I'll drag this upwards. You can see that it rotates as well as it moves along the axis. And I'm just going to select this top face here, the seal, and I'll zoom in and select the bottom face of the T and press OK. Now before moving on, I'm going to create another mate. So there's a number of different ways of doing this, but essentially this T right here can rotate in any direction right now. That's because we haven't set any kind of mate restriction onto the direction of this T. Okay, so to fix that, what I'll do is I can either right click this T and fix it, which locks it into place. That's option number one. The other option, I'm just going to create this thing as a floating right there. Okay, the other option, of course, is to create a mate which locks the relative position of this T to, say, the base part, which is the well casing. So I can select the two and select lock, and then press that. So that locks the position. So this T can no longer move based on this well casing, which is another option to us. I'm going to go ahead and just delete that mate. And the other one, which I find to be more useful, is to create a mate between any of the faces here. So we'll just select this face, and then some sort of relative geometry that makes sense. So I'm going to pick this right plane, and I'll set those parallels. So now, no matter which way I orientate or whatever way that I have my components laid out here, this T face will always be parallel to that right plane. Okay? This is really important because as we move on through this assembly, you'll find there are a lot of unknown orientations of components because we haven't built the base yet for this pump. So there's a lot of unknown variables. Those unknown variables will cause a lot of headache when you're trying to manipulate the position of your components because there's just too many free variables, there's too many components that are allowed to move. So start by fixing this T so that this T cannot move, and it'll save you a lot of time and headache later on. Next thing I'm going to do is insert the guide cylinder. So I'll select the guide cylinder and just drop that in there. And I'm going to mate the cylinder here with the T concentrically. Okay, now I'm going to go ahead and select this top face of the T and the bottom face of the cylinder, just like that, and you'll see there that they coincidentally mate to be flush. Then I'll go ahead and press OK on that. Alright, so let's zoom out. Here's where we're at. Okay. Now I'm going to insert the stroke slide. So I'll go back to my stroke slide and place that like that. And I'm going to start by making a concentric mate between the cylinder of the stroke slide and the cylinder of the guide cylinder. Okay. Now you can see here I can move this up and down and rotate it. So we'll select one of these cylinders exiting the stroke slide. Pick any one, doesn't really matter. And we'll also select that T, the cylinder exiting the T, and we're going to make those perpendicular. Okay, so now we can see here that the stroke slide can move up and down, right, as it's supposed to in the pump design, but it can't rotate left or right because it's fixed to the 90-degree perpendicular mate between the T and the stroke slide. So make sure that you're following these steps of how I am mating these components, because if you miss out something like that perpendicular, you're going to have too many degrees of freedom in your components, and it's going to be a huge pain later on. Okay. Now we can go ahead and keep this. I know in your lab manual it says to lock the movement of the stroke slide. You can go ahead and just keep it free for now. I don't think it causes any issue in my way of mating. So you can just go ahead and leave it the way it is. Next we'll insert the offset link. So we'll drop one in there. And I'm going to go ahead and insert two since they're so similar. Okay. Now, I don't know if you guys can see that, but for me it's pretty obvious that one of these holes is bigger than the other, right? An easy way to check is to look at the gap between the hole and the outer radius, the fillet that we made. You can see here this one's got less material, this one's got more material. So this is the larger of the holes. This is the 30mm hole, and then this is the 24mm hole. So what we want to do is mount the 24mm hole on the stroke slide, which you can see here, and we'll mount the 30 above. So if you remember from our first labs 1, 2, and 3, I said that it's always a good idea to rotate your components and put them in their position before you start mating. I'm going to do that here by moving with triad so I can get the correct orientation of these two links. Just like that, something like that. Doesn't have to be perfect, but just enough to help you out. And now I'm going to go ahead and mate the cylinder. Okay. I'll select that cylinder there. So that's the concentric mate that I need. And now I can still drag this in and out. So I will create another mate on this surface here and the inside surface of the link. Just like that. Now I'm going to do the same thing for this link here. You'll have to excuse me, my SolidWorks is being very difficult today, and it keeps zooming in and out for me. But anywho, we'll select the cylinder of the stroke slide, and then we'll zoom in here and select the inner cylinder of the link. You can see there it snaps concentrically, perfect. Now I'll pull this away, and all I gotta do once I zoom in here is select the inner face of the link and this face right here on the slide, and you can see there they mate coincidentally, and there you go. Now you might find it easier to just sort of line these up vertically for the next step, which will be to add the pivot block. So I'll go ahead and exit this dialog box, insert the new component, which is the pivot block. So mine's not open, I'll just open it from that dialog box and drop that guy right there. Okay, now I'll rotate this something like this. Okay, and I'm just going to move it roughly in place. That's pretty close. Now I'm going to go ahead and make these components here by selecting that cylinder and the cylinder of the link, and then the same thing on this side, that cylinder and the cylinder of the link. Okay, we'll zoom out now. There we go. Okay. Whoops. I think I may have made a mistake with one of these mates. Yeah, okay, so I made a mistake here with this last mate here. I'll just quickly edit that. Actually, that's very strange. Ah, there we go. I'm just going to create another mate here. I'm not sure why it's giving me such an issue. There we go. Okay. Looks good. Yeah, I think the issue there was one of the SolidWorks gremlins not understanding my coincident mate. But there we go. That works fine now. So now, after creating those mates here and having the pivot block mounted to these offset links, we're going to go ahead and insert the pivot support. Again, insert components, pivot support, and just drop that somewhere in space. I'm going to rotate it to match the orientation of the rest of the components, and place that somewhere like that. Now I'll zoom in and mate that cylinder with this cylinder concentrically. Okay, and now I'll go ahead and select this face and whoops, that face there and this face there, and mate those coincidentally here. You can see that, and there we go. So now this is where I think a lot of the confusion from mating this assembly comes from. We have a lot of unknown variables in terms of rotation, in terms of position, and we'll start to mate some of those to fix some of the issues of, you know, we can see here by lifting this pump, it's not exactly operating as we expected. So we'll start fixing those immediately. To do that, I'm going to select the shaft of the pivot support and the shaft here of the well casing, and I'm going to select parallel. So parallel just puts those axes parallel to each other, and you'll see here it just means that they'll always be vertical relative to each other, which is exactly what we want. The next thing I'm going to do, and this is my suggestion to you, I know it doesn't mention it in the lab manuals, is to select the cylinder again of the pivot support and the cylinder of the well casing and set up a distance mate. Okay, now you can pick any arbitrary dimension as long as within, you know, a certain range. So I like to go with 250 millimeters. Okay, and that locks my pivot support to 250 millimeters in this direction here from the well casing. I'm also going to do a distance mate from the bottom here of the well casing to the bottom of the pivot support. Same thing, distance, and in this case I'm also going to do 250 millimeters. Now this is just my suggestion. This is not something that's covered in the lab manual. This I have found just makes it a lot easier for me to assemble this pump. So what that does is it locks the position of this pivot support to two variables, which are the distance away radially from this case and the distance vertically from the bottom of the case to the bottom of the pivot support. Now you will need to know those dimensions when you're creating your base for the Lab4 mini design project 4. which you're asked to create a base that this pump will stand in. Now your base, of course, you're going to have to create two circles, one circle or one cylinder hole for this pivot support to mount to, and then another cylinder hole for this case support to mount to. So if you think about it, that's essentially what I've done right here by creating those two dimension mates, right? I created a distance mate between the bottom here, which shows the relative distance between the bottoms, and then I created another distance mate which shows the distance between the pivot support and the case of the pump here. So when you're creating your base, my suggestion is to create these mates, those two mates that I've just set up, right, which lock the position of this support, and then replicate those mates in your base by selecting a hole that is, say, 250 millimeters away from this pivot support to that case, right, so it matches my mate, and then make sure that your extrusion is whatever depth that this depth is here. You can play with these dimensions. It doesn't have to be 250. That's just my personal preference. You could do 300, you could do 175 perhaps, but just fix that so that this pivot support doesn't move around, and you'll have a lot easier time creating the rest of the assembly. Now once my pivot support is in place and I've created those mates, I'm going to go ahead and drop in the handle, which of course is not loaded right now. So I'll go ahead and drop the handle in like that. I'm going to rotate my handle using move with triad. Alright, something like this. Okay. Alright, that looks roughly in place. Now I'm going to mate it to the top face of the pivot block. Okay. So it'll automatically pick coincident, which is exactly what I want. And now we can see that my pivot block and handle are flush with each other. Of course, they're just all over the place in terms of angle and other dimensions. So to fix that, I'm going to select this edge here of the pivot block, and I'm going to select the edge, either one, doesn't matter, of the handle, and I'm going to make these parallel, not coincident, parallel. So now I can still move my handle forward, backward, up, down, left, right, but I can't change the angle of it, which is perfect. Now I'm going to select the front face of the pivot block and the front face of this handle here. Okay, and I'm going to set up, whoops, let's try that again. We'll mate the front face, it's important that you click the face, and the face of the pivot block, and I'm going to set up a distance mate once again. Okay, and I'm going to set this distance mate in the dialog box here to 75 millimeters. Okay, now you can see my handle is on the, it's past the pivot block, and that's not what we want. What we want, if you look at the lab manual, you'll see it in steps, what step is this here? Step 23, I believe. So if you look at your lab manual, page 45, you'll see that, page 46, okay. You'll see in page 46 that we want the handle to be recessed here from this face. So I'm just going to go ahead and select flip dimension, okay, and you'll see here that it places the handle further back, still 75 millimeters, but on the opposite side of this face. Go ahead and set that. Then we'll just zoom in here. I'm going to select this edge and select a distance mate of, I believe it's 64 millimeters. Let me just double check that. Yep, 64 millimeters, and press OK. So that lines us up right in the middle. You can see there. And that's mostly it. Now we just have to put on some components here. We need the 24 millimeter nuts here. We have to put our bolt here and a bolt here in the nuts. But this is essentially the majority of the pump. To do those nuts very quickly, I'll just do the 24. I'll select the 24 millimeter nut and just place two of them. One there and one there. Now I can zoom in here. Alrighty. And select mate. I can mate. Now in this case I'm going to simplify things by selecting this edge right here. So you can see that the inside edge of the nut. I'll select that edge and then select the inside edge right here of the link. Okay. Oh, that's my mistake. I selected the wrong edge. Concentric. There we go. No, okay, it works. There we go. So we have the concentric mate for the nut, so it matches the thread there. Now I'll just zoom out here, select this face of the nut right there, and this face of the link, and press OK. Now I'll just move over to this side and do the same thing. Select the edge of the nut and the edge of this link here. It's kind of difficult to find here with all the other thread lines, and then pull it back, select that link, and select the face of that nut, and there we go. Okay, so now we have our two 24mm nuts mounted in their place. We can zoom out here, and you'll see there this majority of this side here is complete. We'll just have to add the outlet pipe. We'll do that last. Now I'm going to find the 30mm bolt and place two of those, one here and another one. Find it again. 30mm bolt, and place that guy over here. And I'm just gonna mate these by taking the cylinder of the bolt here and the cylinder of the pivot block, mating those concentrically. Now I'll select the face of the head there and the face of the pivot support and mating that. Same thing over here. I'll take the cylinder of the bolt and the cylinder of the pivot block, mate that. Take the face of this link, and I'll just select the face of that bolt head and mate that just like that. Now I can go to insert components and drop two of the 30mm nuts. We'll put one there and another one right there. Now I'll just mate again the edge to that edge, so it gives me a concentric mate. Perfect. I'll drag the nut away so I can see the faces. Select the face of the link and the face of the nut, and just like that. Oops, I think we have a freeze here in SolidWorks. You can do it, come on. There we go, okay, we're back. Now we had a little bit of a hang in the SolidWorks program, but that's not an issue. Okay, so we'll continue here with the edge there on the nut, concentric mate. Now I might just have to drag that nut there. No, it's lost. Okay, I'm just gonna hide. There we go, pull that guy out, select the face there of the support and the face of the nut, and mate that there. Okay, so now I'm just gonna unhide my pivot block because we had an issue there with the component. And now we'll see we have a vast majority of this pump complete. It is a pretty complex assembly, considering up to now we've basically just done the cabinets, which are just very simple square, components with multiple repeated mates, being the door hinges. But this one here is a little bit more difficult. Just take your time, follow step by step with the video. If you're getting frustrated, just zoom out. Remember what I said about the pivot block here, the pivot support. Make sure that thing is fixed in place so everything works nicely. And you can see here now, I can operate my pump as it's intended to, exactly as we expected, right? There's no parts floating around, nothing is moving, and it works, near flawlessly. The one thing I will suggest you guys set up is a distance advance mate. So this is just something that goes above and beyond what we expect you guys to hand in for your design projects, but it's something that you can learn very quickly. I'm going to select the top face of this T, right? So you can see this here. Let me just zoom out. Today, please, SolidWorks. Okay, there we go. We had a little bit of a freeze again. I'm going to select the top face of that T and the bottom face of the stroke slide, and I'm going to set up a new mate. So over here in the mate dialog box, I'm going to select advanced mate and distance. So this advanced distance sets a maximum and minimum, which I'm going to set as 200 millimeters as a maximum and 0 as a minimum value, and then press OK. And you can play around with these maximum minimums, but a minimum of 0 makes sense because you don't want the stroke slide to go into the T, right? So you want it to stop right at 0, which is perfect, and then you want it to extend fully to the top, which is about 200 millimeters there. So here you can see with that mate in place, I can't go through the T, and I also can't extend past the top of the guide there, which is exactly how we want this pump to function. So that takes a whole 20 seconds maybe to set up, and it just makes your pump that much more realistic when you're modeling it here in the assembly. Okay, the last component is the output pipe, which I will just drop here next to its location. I'm going to once again move with triad, okay, just like that, and then mate very easily. I'll just zoom in here, select that cylinder, select this cylinder. That's a concentric mate. Now I'll mate here the output face here and the output face there. I'm going to set a quick distance mate, okay, 10 millimeters, so that this, 10 millimeters there, so that this pipe is recessed into the T, okay. If you have this issue, which almost everybody will have because it likes to default to the outside of the T, you just have to quickly select flip dimension, which inputs the pipe on the inside of the T by 10 millimeters, then press OK. And then the last thing you'll have to do is just make a parallel mate between the bottom face here of your, let's just zoom in here, the bottom face of your output pipe and say the bottom face of the casing, just something that we know to be flush with the ground. So like that. We'll select parallel and then press OK, and if we zoom out you'll see that the output pipe is now pointing downwards as we expect it to. Right, there we go, we can see that there. So the output pipe points in the direction it should, the pump functions as it should, we have all the components placed, and we've already kind of started here, as I mentioned earlier. We've already started with our base design by setting those two parameters, the location of the pivot support relative to the base of the block and the location of the pivot support radially from that well casing. So that's just how I assemble it. I mean, if you were to follow the lab manual, I'm sure you would find that's a little bit different. This way works best for me, so I suggest, if you'd like to ask questions in lab based on how to assemble it, follow my steps first, and then I can help you guys troubleshoot your problems. As I mentioned before, the distance mate between, let me just pull these up, the distance mate between the pivot support and well casing, you can adjust those parameters to however you would like to manipulate your pump so that it fits exactly the way that you envision in your base, and then just take those dimensions and create your base from that. Once you're all done with this assembly, just go ahead and click save, and make sure of course that you have it saved in your Lab4 folder as pump assembly, and then you can go ahead and start working on your mini design project 4.